Hello and welcome to the Quiz 12 review. So as always, the thing that I really want you to review is make sure that you are doing your daily lessons and your homework. If you don't have those done, this video could help you and you could get away and you could get a decent grade on a quiz, but if you don't practice over and over, it's going to be harder to do well in the AP exam, and as the end of the year gets closer and closer, I want to make sure that you're really understanding major concepts well. So a couple things that I want you to look through is, one, make sure that you look through your daily lessons from 177 and 197 specifically. There could be older stuff on there, but that's kind of the main part of this. And your homework from 1 to 31, and also free responses. So make sure you're looking through those also. Okay, on this review sheet you should have already, it's telling you to find h prime of x. So anytime you're given an integral, like h of x, and you're finding the derivative of the integral, what you're really doing is you're taking this stuff on the inside, and I'm substituting x cubed. So I'm going to have 4x cubed. I've got to be careful here because it said t squared, so I'm going to say x cubed squared minus 2. And there's going to be somebody in the room, don't let it be you, that forgets to multiply by the derivative of this upper limit of integration. Because what you're really doing is chain rule. You're taking the derivative of the outside, the derivative of the integral is just the stuff in here, leaving the inside alone, leaving the x cubed alone, times the derivative of the inside, which the inside in this case is x cubed. If I would reduce, or if I would simplify that, 4x cubed times 3x squared is 12x to the 5th. In the denominator, I would have x third squared would be 3 times 2, x to the 6th, minus 2. So this is h prime if this function is h of x. The next one, it says evaluate h prime of x for a given value of x. So like if it said h prime of 2, I would have to substitute in 2 up here. If it said h prime of 5, I'd put in 5 up here. 1, whatever it is, you're just putting it back in here. Okay, the next one, it says integrate using pattern recognition. Use substitution, I gave you those two problems specifically, so look at those two problems. One of them will be on here. But integrate using pattern recognition. What I mean by that is if you see that there is a function within a function of some sort, like there's lots of homework problems where you have to find, maybe it will be like an integral of x squared, and here it will say like cosine of, I don't know, x to the third dx, something like that. What you have to recognize is this is the main function. So an antiderivative of cosine is going to be sine, leave the inside alone, plus c. And then you say, okay, well, I'm going to check to make sure that I actually got the correct derivative, and I can see the derivative of sine is cosine, leave the inside alone, times 3x squared. But that's not quite what's up here, so you have to multiply by 1/3 to get rid of that 3. That's what I'm talking about by pattern recognition. Particular solutions to differential equations, do yourself a favor and do the free responses. There are so many problems like this where there's like a dy dx is equal to something. Maybe it's like x squared times y, and then you have to separate and get, this would be like 1 over y dy is equal to x squared dx, and then you have to do the you have to anti-differentiate, find the antiderivative, and then find that value c. Just do yourself a favor, make sure that you know those. It even says try problems like free response, and it gives specific ones, 2008 and 2005. If you don't know them, ask me or look at YouTube. There are people explaining them step by step. You can skip to the parts that you need. Okay, the next one says be able to determine absolute minimum, absolute maximum. Absolute mins can happen at endpoints or where the derivative is 0. So mins and maxes, those are the things I need to check. So if I'm looking at a function like this, f of x, and I have this integral from 4 to x of f of t dt, and over here I've got f of t, and I can see they match up. It says write the coordinates of the absolute minimum. If you're talking about the absolute minimum, minimums can occur at endpoints where the derivative is 0. So if I'm thinking about the derivative, that would be the function on the inside. So f of x, the derivative of x is just 1, so you don't have to do that, but it's good practice. If I'm looking at this and I'm saying, well, the derivative is f of x, I need to see where is that 0? Right here. And I can also see that it goes from negative to positive. So if the derivative is going from negative to positive, I do have a relative min. It could be an absolute min. I also need to check endpoints, so it's 0 and it's 7. So what you're going to want to do is you're going to want to check f of 0, f of, which other one? F of 1, 2, 3, 4, and f of 7. Then the way you do that, do you see how this goes from 4 to, if I would put from 4 to 0 of f of t? These match, so you're finding the area under the curve. Ones like that aren't going to be quite as easy because you can see 4 is less than, or 4 is greater than 0, so you're going to have to switch it and make it negative from 0 to 4. But then it's just the area under the curve, area under the curve, area under the curve. So in this one, if you're finding the coordinates, it also will tell you once we get this far, and you can take a look at your answer sheet, which I also provided for you. But after you do all this work, you end up finding that f of 0 is, I have to look, 8, f of 7 is 4.5, and f of 2, I can't see it on here, it's kind of hard to see. So look through the answer sheet. I know this is going to be negative 4, negative 4, and up here you get 4.5. So that should help you find some of these. Work through this problem. Don't just go along with me and say, oh, she's doing it for me. Like, actually look at it. So the coordinates, make sure that you have an x and a y value, or in this case, x and f of x value, and you're considering the endpoints. The next thing is x equals 2 considered a point of inflection? Points of inflection happen when the second derivative, so f double prime, changes signs. So positive to negative, or negative to positive. Okay, so if this is a graph of f prime is f of x, what I really need to know is when is f double prime changing from positive to negative, negative to positive? Or I could say, when is f prime changing from increasing to decreasing, or decreasing to increasing? Really, when is it going to have a max or a min? And I can see right here at x equals 2 that f of x, or I'm sorry, f of x is going to have a point of inflection, and the reason is because f prime has a relative min. That means f prime is changing from negative to decreasing to increasing, which means f double prime is changing from negative to positive, which is what we wanted. So that's f prime, or in this case f of t, because we said that they were equal to one another over here. Capital F prime is changing from decreasing to increasing in x equals 2, which means f double prime is changing from negative to positive. So I would say yes, that is true. On the other side, I'll get a new piece of paper. That one's kind of hard to see. There's one. On the other side, there's just some extra problems for you to try. So I'm going to hope that this kept recording because it just had a low battery, but we'll see. So on this one, there's extra problems. So what you need to do is read this at first. It says g of x, and it gives you some extra information up here. And then 2/4 circles in one line segment. So it's kind of nice because it tells you that this right here is a quarter of a circle and this over here is, and then it also says one line segment. So up here it says find the value of g of 3. So g of 3, I'm going to go up here and it says 1/2 x squared. X is what I'm substituting, so I'm just going to say 1/2 3 squared plus, I can see I have another x right here, so I'm going to say 0 to 3 f of t dt. This is the graph of f. I can label it really big. So that means because these match, I'm finding the area under the curve of f of t. That's not the only reason, but it's a good one to remember. So I'm going to go from 0 to 3. And if I do that, it's not totally awesome because right here, I have to find out what that point is and make sure that it crosses at a nice place. If I do some extra work here, I can see that this line, if I count over 1, 2, 3, what's another one? Even right here, it has a slope of 2. On mine it says 3, negative 3, and I can see that this is going to be 1, 2, 3. So I've got this point, 0, 3, 3, negative 3. Negative 3 minus 3 is negative 6 over 3. I can see I have a slope of negative 2, just because these are kind of hard to see down here. If it has a slope of negative 2, and I can see that it has a y-intercept of 3, and I want to know when y is equal to 0, I would get negative 3 is equal to negative 2x, x is equal to 3 over 2, so that actually is 1.5, which is nice. You don't just want to assume right away, though. Okay, so when I'm doing this now, I can do 1/2 base times height and figure out that this up here is going to be 2.25. Down here, it's exactly the same thing except for negative because it's under the x-axis. And so the next one, what is this? From 0 to 3. From here to here, 1, 2, 3. These two cancel each other out, so you're going to end up just adding 0. The answer then is 9/2 or 4.5. The next one, g of negative 4. It's really similar to the last one. I'm still putting negative 4 in here. But this time I'm going 0 to negative 4 of t dt. Be careful about this. This is going to be 16 divided by 2. I get 8. But then this one, I'm going to switch this around, so I'm going to make it minus instead of plus. So then I'm going to go 0 to 4. From 0 to 4. Oh, should I have said that? Hold on. Or, I'm sorry. I switched it around and didn't actually change it. There we go. Negative 4 to 0. That looks better. Negative 4 to 0. If I go over here, this is a quarter of a circle. So if I try to find this, I would say 1/4 pi the radius squared. The radius in this case is just 1, but it's below the x-axis, so I'm going to make it negative. So I would have 8 minus, it's going to be a negative, this would be 1/4 pi, plus this area would be 1/4 pi 1, 2, 3. So I would have 9 over 4 pi here. If I add these two together, I get 8 over 4 pi or 2 pi. And then I'm subtracting, so I did have 8 minus 2 pi. That's what that's equal to. Okay, g prime in this. So if this is g of x, g prime of x is going to be 1/2 x squared, so this would be 2 times 1/2 is 1 x. We knew exponent would just be 1, plus a derivative of the integral is the stuff on the inside with this substitute. So f of x, the derivative of x is just 1. If I go over here to g double prime, I'm going to say g double prime of x, I take the derivative of this part. So the derivative of x is just 1 plus, this is f of x, the derivative of f of x is f prime of x. This is the slope. Here is just the point on the graph. So I'm going to say, if I want g prime of 3, I'm going to say 3 plus f of 3. Over here, if I want a g double prime of 2, say 1 plus f prime of 2. And then the way I look at this on the graph, I'm going to say 3 plus f of 3 is just going to be the point. So I'm going to go 1, 2, 3, down. Hey, look, I see it's negative 3. It's even written for me. So here I get 0. And this one, I would have 1 plus f prime of 2. This is the slope of f at 2. At 1, 2, we already figured out the slope of this line was negative 2. So over here you get negative 1. My best advice is do your homework. Make sure that you are keeping up to date on that you are asking questions when you have them, that you're looking stuff up as far as like YouTube or other places. Just all good stuff that would actually help you practice and stuff that I'm telling you to look up in class, not other things. But I think you can do really awesome on this. Do not give up. It's really hard. It's the beginning of March. Spring's coming. It'll be okay. Hold on. We've got this together. Happy studying.